All right, today we are diving into the ultimate origin story. I mean, the biggest one there is, the story of our planet Earth. We're going to travel back 4.6 billion years, starting from the very beginning of the universe itself, all the way to the world we see around us today. So let's get into it.
Have you ever just looked up at the night sky or stood by the ocean and really wondered, how did all of this, our home, actually get here? Well, that is the big question we are tackling today, and we're starting right at the very, very beginning. To really tell the story of Earth, we've got to zoom out. I mean, way, way out. We can't just start with the planet. We have to start where everything started, the birth of our entire universe. Now, you've probably heard of it, right? The Big Bang Theory. This is our best scientific explanation for how it all began. And the core idea is pretty mind-bending. Everything you see, all the matter, all the energy, was once packed into a single, unbelievably hot and dense point. And then it exploded, and it's been expanding ever since. Just try to imagine it. Everything in the cosmos, every star, every single galaxy, all of it squished into a point smaller than an atom. Scientists call this a singularity. We're talking about a spot with infinite density, infinite temperature. And this is where it all began, about 13.7 billion years ago. It's wild to even think about. And then came the bang. In a fraction of a second, that tiny point just exploded, expanding faster than we can even comprehend. And as it expanded, all that pure energy started to cool and turn into actual matter. And here's the crazy part. Within the first 3 minutes, just 3 minutes, the universe had cooled down just enough for the very first atoms to start forming. The speed of creation was just staggering. Okay, so the universe kept expanding and cooling down, and as it did, a new force started to take over: gravity. It began to work its magic, pulling together these massive clouds of gas and dust, and these became the cosmic nurseries where stars, including our very own sun, were born. So how do we get from a bunch of stars to actual planets? Well, the leading theory is something called the Nebular Hypothesis. Basically, it suggests that our sun, when it was just a baby star, was surrounded by this huge spinning disk of gas and dust. You can kind of picture it like a giant cosmic frisbee spinning around the new sun. So you have this spinning disk of stuff. Gravity gets to work again, pulling little bits of dust and gas together into tiny clumps. These clumps start bumping into each other and sticking together, a process called accretion. They get bigger and bigger, forming these things called planetesimals. And over millions of years of collisions, these planetesimals smashed together and grew into the planets we know today. And right in the middle of all that cosmic construction, through that exact same process, that's when our planet Earth was finally born, about 4.6 billion years ago. So happy belated birthday to our world. But listen, the Earth that was born back then, you wouldn't even recognize it. It was nothing like the blue and green world we live on. Its early days were violent, molten, and just completely alien. I mean, just look at this contrast. Early Earth was a barren, rocky hellscape, super hot and volatile. Its atmosphere was just this thin, useless wisp of hydrogen and helium. Now compare that to today, a world bursting with life, covered in oceans, with an atmosphere we can actually breathe. So what happened? How did we get from that to this? Well, one of the first really crucial things that happened is a process called differentiation. The young Earth was basically a giant ball of molten rock. And just like when you let salad dressing sit, the heavier stuff started to sink to the middle while the lighter stuff floated to the top. The heavy materials, like iron, sank to form the core, and the lighter rock rose up to form the crust. And that whole separating process, that's exactly how we got the layers of our planet that we learned about in school. It created that solid inner core, the liquid outer core, the massive mantle, and, of course, the thin crust that we're all living on right now. Okay, so we've got a planet with layers, which is a good start, but it's still just a hot, barren rock. It's time for a serious planetary makeover, starting with creating an atmosphere and the oceans. This didn't happen overnight. Our atmosphere evolved in stages. First, that early, thin atmosphere of hydrogen and helium, it got completely blown away by the sun's solar wind. So Earth had to make a new one, this time from the inside out. Volcanoes were erupting constantly, releasing trapped gases like water vapor, a process we call degassing. All that water vapor rose up, condensed into clouds, and then it started to rain. And it didn't stop for millions of years. Can you imagine that? A rainstorm lasting millions of years. All of that water collected on the surface, filling up all the low spots. And by about 4 billion years ago, the very first oceans had formed. Earth was finally no longer just a dry rock. And once you have oceans, well, that's when things get really interesting. Because it was in these new warm oceans that the most incredible transformation of all was about to begin. The final piece of our origin story, the arrival of life. Scientists figure that around 3.8 billion years ago, the first very simple forms of life began to evolve. Now, we're not talking dinosaurs yet, not even close. We're talking about tiny, microscopic organisms, kind of like modern blue-green algae. But these little guys, they were about to change absolutely everything. See, these tiny organisms developed a revolutionary new trick: photosynthesis. They figured out how to use sunlight for energy. It was a brilliant survival strategy. But in the process, they released a waste product. And that waste product was oxygen. To them, it was just trash. But to the future of the planet, it was everything. Now, this didn't change the atmosphere overnight. For over 1 billion years, all that oxygen they were making just got absorbed by the iron in the oceans. But eventually, the oceans couldn't hold anymore. And around 2 billion years ago, oxygen started pouring out into the atmosphere. This was a total game changer, paving the way for all the complex life that needs oxygen to breathe, including us. Okay, so wow, that is one heck of a story, right? From a tiny dot to a living, breathing planet. But so what? Why does this ancient history actually matter to us right here, right now? Well, for anyone studying physical geography, especially those of you preparing for the civil services, this isn't just nice-to-know info. This is the absolute foundation. Understanding how the Earth's layers formed helps you understand plate tectonics and earthquakes. Knowing how our atmosphere was built is critical for understanding climate. It all connects. And mastering this conceptual base is just essential. Really, it all boils down to this simple idea. Every single thing about our world, every mountain, every ocean, the very air we breathe, is a direct result of this incredibly long and dramatic history. If we really want to understand our present, we absolutely have to understand our planet's past. We really hope you enjoyed that journey through time. If this explainer helped you connect some of those big ideas, do us a favor and hit that like button, and make sure you subscribe to Mission Civil Services for more deep dives just like this one. Thanks so much for watching, and we'll see you in the next one.